Looking at two more identities today. We're looking at the power reducing identities and we're looking at the half angle identities. We're going to use both of these to do what we've been doing the last few days, and that is evaluate trig expressions and solve trig equations. So, power reducing identities are coming up on the next screen. So write these three down real quick for me. Power reducing identities. And what do they call this power reducing? You're taking it from the square and turning it into something that's not a square. So you're taking it from the square to the power of 1. So that's why it's called power reducing. Okay, half angle identities. There are 4 of those. And after we get through all of the identities, we've got one more day of identities, and I will have a sheet that has all of these on there for you to use. All right, first thing we want to do is use the power reducing to help us solve a trig equation. Notice it does not say between 0 and 2 pi, so what does that tell me about my answers?
Plus 2 pi.
I need the plus 2 pi in. So I want to use power reducing to help me solve this trig equation. So what do you guys recommend we do if we're going to do that? Change cosine squared. We're going to change cosine squared. What does cosine squared equal?
1 plus cosine squared over 2.
So in this case, since we're dealing with x, we're going to put 2x over 2 minus cosine of 2x equals 1/2. So I took the cosine squared out. I put 1 plus cosine 2x and it's over 2 in its place. Now what do you recommend we do?
Get the cosine to the
I eventually want to do that, but I've got to do something before I do that.
multiply by 2.
Multiply by 2, very good. If I multiply by 2, I end up with that. All right, what's going to happen to my 1s? They're going to cancel. What do I get when I put my cosines together?
Negative cosine.
Negative cosine of 2x equals 0, which means cosine of 2x equals 0. So I want to ask myself, when does cosine equal 0? At pi over 2 and 3 pi over 2. Don't forget the plus 2 pi n. But what is normally in that spot? Or theta, or just an x. And we usually just say x equals this, but since 2x is here, we have to say 2x equals that. But I'm not interested in what 2x equals, I'm interested in what x equals. So what am I going to do?
Divide by 2.
I'm going to divide by 2. So what's pi over 2 divided by 2? Pi over 4. And I have to divide the 2 pi n by 2 as well. What does that give me? That gives me pi n. And divide the 3 pi over 2 by 2, I get 3 pi over 4. Divide the 2 pi n by 2, I get pi n. So there are the solutions to my equation. Questions on that? I did pi over 2 divided by 2. Divided by 2, how else can I think about dividing by 2?
Multiplying by 1/2.
Multiplying by 1/2. So if I go pi over 2 times 1/2, that's where I get pi over 4. 3 pi over 2 times 1/2, that's where I get 3 pi over 4. Okay? So this is exactly the same as what we've been doing, except for that initial start where I used my power reducing. Once I use the power reducing, then it's just another problem, another solving trig equation problem that we've done before. Alright, so that's all we're going to do with the power reducing is use it to help us solve triangles, or solve equations. Now we want to use a half angle identity to help us figure out what tangent of 7 pi over 12 is. So how am I going to use a half angle identity, or what do I need to do to get started to use a half angle identity to evaluate this?
Plug that into
I need to pick one of those formulas, right?
Yeah.
Notice there are 2 of them. Which one of them would you pick if you had a choice and why?
the second one.
The second one because it's positive?
Yep.
I would choose the first one.
Why?
Why do you think I'd choose the first one versus the second one? I like the first one better than the second one because I like as few things as possible in my denominator. Okay? I like my denominator to be the smallest as possible, so that's why I like the first one versus the second one when I get a choice. Okay? So, we're going to use tangent of theta over 2, and we want 1 minus cosine theta over sine theta. So that's the identity we're going to use. So what do you recommend we do next?
Find sine and cosine.
Find sine and cosine of what? Not 7 pi over 12.
Would you draw the triangle?
I would not draw a triangle. This is the confusing part about this problem, and once you see it, it shouldn't be confusing anymore. What does 7 pi over 12 represent in my formula? What does it represent?
No, the opposite over there.
In this formula over here, what does 7 pi over
The
12
theta
represent?
over 2.
That represents theta over 2. So 7 pi over 12 is my theta over 2. But what do I need to be able to plug into this formula?
Over 2.
I just need theta. So what do I need to do to get theta by itself right here? Multiply by 2. So that gives me 14 pi over 12, which reduces to what? 7 pi over 6. I don't know where 16 came from. So theta is 7 pi over 6. So 7 pi over 6 is what I need to be plugging into my formula. So it would be 1 minus cosine of 7 pi over 6 over sine of 7 pi over 6. Okay, and what do I need to know to be able to evaluate these two things?
Reference angle and quadrant.
Reference angle and quadrant. What's my reference angle? Pi over 6. So what's cosine of pi over 6?
What happens? No.
Square root of 3 over 2. If cosine square root of 3 over 2, that means sine has to be 1/2. What else do I need to consider? The quadrants. So what quadrant is 7 pi over 6 in and why? It's the third. Why is it the third, Kurt? Because 7 is 1 more than 6. So since my top number is 1 more than my bottom number, that tells me I'm in quadrant 3. Or, yeah, how else could I figure that out if that gives me trouble?
Degree.
Yeah, put it in degrees and then I'd be able to see it a little bit easier. But if you can see it in radians, then you're saving yourself some time. So both of these, since we're in quadrant 3, need to be negative. Both of these need to be negative. And then what do I do to clean that up? Or what do I need to do?
Multiply by 2.
I need to multiply by 2. So that gives me 2 plus radical 3 over negative 1. And we distribute that negative 1 through, and we have determined that this thing equals negative 2 minus radical 3. So walk me through what we need to be able to do to use a half-angle identity to evaluate a trig function. What did we do? We need to figure out what theta is. And what did we do to figure out what theta was? Multiply by 2. So we're going to take our angle, we're going to multiply it by 2 to get theta. And once I have theta, what do I do? Yeah, pick my formula, plug it in, and then solve it. That's all we're doing there. Okay, let's try another one. So I want to use a half-angle identity to help me figure out what sine of 165 is. So a half-angle identity to figure out what sine of 165 is. So what do you want to do to get started?
Multiply by 2.
Multiply it by 2. So that means theta needs to be, what does that give me?
330.
330. So my angle is 330. Okay, now what? Plug it into my formula, and my formula is plus or minus the square root of 1 minus cosine over 2. Well, I need to know what quadrant it is, so I like to initially write it first and then do those two things on the side. Everybody understand what I've done so far? No? What can I clear up for you, Bob?
I don't understand how you got 3 3.
I took this times 2.
Why?
Remember?
Theta over
8
2.
over 2.
Remember, my formula is theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. So that means this right here is equal to theta over 2. So I did theta over 2 equals 165, and that means theta equals 330 when I multiply that 2 over. Because I need to figure out what theta is because my problem has theta in it. So I multiply by 2 to figure out what theta is. Once I figure out what theta is, then I plug that in to the formula. Okay, what do I need to be able to evaluate cosine of 330? reference angle and the quadrant. So the quadrant should obviously be 4. What's my letter for quadrant 4?
C.
C. And what's my reference angle? 30 or, yeah, pi over 6. So, what is cosine of 30? Square root of 3 over 2. And what is cosine in the fourth quadrant? Positive. So that's what I like. Now I just need to clean it up to get my answer. So what do you recommend we do to clean it up? Multiply by 2. So 2 minus the square root of 3 over 4. And we should know how to take the square root of 4, correct? So that ends up being 2. Now notice, this has a plus or minus in it. I don't want plus or minus in my answer. I want to choose which one. I want to choose one of those two. So how do I determine whether or not I want the plus or whether or not I want the minus?
Quadrant.
What quadrant of what?
The original.
The original. I need to know what quadrant is this in and then what is sign in that quadrant. So what quadrant is 165? Second. So what does sign need to be? It needs to be positive. So my answer is sine of 165 equals the square root of 2 minus the square root of 3 over 2. Alright, so walk me back through this to make sure we've got this under control. What do we need to do first? Find theta. How do we find theta? Multiply by 2. Once I have theta, then I find my formula and plug theta in. Okay, and then it's just a matter of figuring out what my trig function is and then simplifying it. On sine and cosine, I have to choose whether or not it's positive or negative on the outside. And how did we do that? What quadrant is the original angle in? And then that tells me whether or not I want the positive or the negative. Okay, so that's using half angle identities to evaluate trig expressions. Now we want to use half angle identities to solve trig equations. So I think it should be, well, there's 3 more, I think. Alright, so I want to use a half angle identity to solve this. Sine squared x equals 2 times cosine squared of x over 2. And this time they want my answer between 0 and 2 pi. What does that mean to me?
No plus 2 pi.
Right, no plus 2 pi n. Alright, so sine squared equals 2 times cosine of x over 2 squared. So where can I put a half angle identity in this? On the right for cosine of x over 2. So that would be 2 times plus or minus the square root of 1 plus cosine x over 2. And then that thing squared. Make sure you understand what I did there. All I did was I replaced the cosine of x over 2, which is that right there represents the cosine of x over 2. Notice there's a 2 in front of it, so that's why there's a 2 there. And notice it's squared, so that's why it's squared there. Everybody okay with that? Now, what happens to the plus or minus since it's being squared? Because if I square anything, what's going to happen to the sign? It's going to be positive. So plus or minus is going to go away because of the square. And what happens with the square and the square root? They cancel each other out. And then what happens with the 2 and the 2 on the bottom? So all I have on the right side is what? 1 plus cosine x.
That was magical.
I see it.
Make sure you see the moves we did there. Okay, now what do you recommend we do? I think I need to change sine squared. What do you want to change it to?
Would be 1 minus
1 minus cosine squared.
1 minus cosine squared is correct. Okay, why do I want to use that one instead of the power reducing? Why do I not want to use the power reducing on that sine squared?
Because then you have cos.
It changes it to two things.
Yeah, that's the problem is when I use a power reducing, it changes my angle to double whatever I started with. And yeah, so in this one, on this one, my angle over here is just x, so that's why I want to use the Pythagorean versus the power reducing. If this was 2x, then I'd want to use the power reducing. But since it's x, I just want to use the Pythagorean. All right, now what?
You subtract cosine of x.
Get it equal to 0, and I'm going to move everything to the right. Why would I move it to the right? To make my square positive. So cosine squared plus cosine. What happens to the ones?
They cancel.
They cancel. So I have 0 equals cosine squared plus cosine. Now what?
Pull out.
Pull out a cosine. Set them equal to 0, so I get cosine x equals 0. I get cosine x equals -1. So when does cosine equal 0? Pi over 2 and 3 pi over 2. And when does cosine equal -1? Pi. So pi over 2, 3 pi over 2, and pi are my solutions to this tree equation. So what should happen if I plug any three of those back into the original?
You should end up with sine squared x.
I should end up with
Sine squared.
You should equals
On both sides.
I would whatever this is, I'm going to get the same thing on both sides. When I plug it in, I should get the same thing on both sides. Okay, that's what should happen.
Same.
All right, no. So 2 times tangent of x over 2 plus 2 times cosine times tangent of x over 2 equals 1. We want our answers between 0 and 2 pi. All right, so what do you guys recommend?
could you take out the
Take out a tangent. That is correct. What else could I do besides take out a tangent? Take out a 2 tangent. Let's do that. So 2 tangent of x over 2. And it gives me 1 plus cosine of x equals 1. Now what?
Replace
You
the
kind of like
Yeah.
separate the 1 plus cosine and make it an answer.
I want to replace the tangent of x over 2, and I have 2 choices. So which one of those 2 choices do I want to use?
First.
first one
I want to use the first one. Why the first one?
because there's less stuff going on in the denominator.
No, I don't want to use the first one.
Second, because you can cancel all the cosine.
I want to use the second one this time because what is in the bottom of the second one?
Those
1,
cancel out.
1 plus cosine, so those 1 plus cosines cancel. So I want 2 times, what is it? Sine
Over 1 plus cosine.
over 1 plus cosine.
And then cancel. You get 2 sine.
Okay, so these cancel. I get 2 sine of x equals 1. You have sine equals 1/2. So when does sine equal 1/2? Pi over 6. The 1/2 is positive, so what 2 quadrants is sine positive
First and second.
in? First and second, so that means this needs to be a 5 pi over 6.
I've got a headache.
Alright, we want to simplify this using a half angle identity. So what does this look like?
Looks
one
like
of the tangent.
what is it?
Well, it's cosine squared.
Half an inch.
It should look like a half angle. Which half angle does it look like? It looks like cosine of theta over 2. So we should notice that this is in this form, so that means I want to take it from this form and turn it into that form. So that means this is going to turn into cosine of something. So the question is, what is that something that should be inside the cosine and why?
So you would square it
What's in this spot in the formula? Theta is. So that means theta equals 6x. And then what's in this spot on the cosine? Theta over 2. So what do I need to do to both sides to get to where I have theta over 2? Divide by 2. So theta over 2 equals 3x. So that means cosine of 3x is what we're looking for. So identify what you want, figure out what theta is, and then find theta over 2. You plug theta over 2 in here, you've got your solution. Okay. So that's power reducing and half angle identities to evaluate trig expressions and solve trig equations.
We need to go home and take a nap.
Alright, so here's your assignment. Notice I want you to use power reducing on 24 and 26, and then I want half angle identities to be used on the other 3.
Just